Hello everyone and welcome to this video presentation. My name is Erik Vich. I'm a PhD candidate from the Norwegian University of Science and Technology, or NTNU for short. This presentation centers around the design of a shore control center for unmanned ships. Now, while this is a maritime technology theme, the story I'll be telling relates to a broader design challenge that we are facing today. Namely, as we implement more AI and automation functions into complex systems design, we are risking losing human control. The genesis of our work was right here. This is the Milliampere 1, a prototype autonomous passenger ferry developed at NTNU. This video shows a 3-hour-long test trial, a proof of concept that marked a major milestone in development because it's successfully avoided targets like a boat and a kayaker, all without human intervention. Now, while 3 hours was a big milestone, it's not quite enough considering that what we really want is 24/7 operation. Also, you'll notice that there are 2 people on board, and they were watching carefully the whole time to see if they needed to jump in and take over manual control. Looking ahead, we can't expect to have operators in this role. It defeats the whole purpose of having an autonomous ferry. So the question we investigated was, how do we provide autonomous service while also maintaining high level of human control from a remote location? We can summarize the design problem with the help of a graph. Let this curve represent the probability density of all operational events X at a given location. Under the left side of the curve are events that have a high probability of occurrence, for example, normal traffic and normal weather conditions. Stuff that is well within the abilities of the AI system. However, there will always be this narrow tail of unlikely events extending to the right. This is the stuff that we're worried about. It might be other vehicles behaving erratically or extreme weather conditions. It's the stuff that must be handled by a human operator. This means that there is a handover boundary somewhere between the AI and human control domains. So what do we need to get handovers to work? Well, we definitely need continuous monitoring. Also, these control transitions need to be smooth. And finally, we have to keep in mind that the uncertainty involved makes this a fuzzy boundary. It won't always be clear when handover is needed. We documented the design process of our shore control center in the paper. This included riding around on an autonomous bus, visiting a remote aircraft control tower, interviewing experts, and hosting various workshops. We incorporated everything we learned along the way into a prototype, and eventually we built a full-scale design from scratch. And this is the result of our efforts. I'm standing in the Shore Control Lab here in Trondheim, and this is where a team of operators can remotely monitor and intervene in the control of a fleet of autonomous surface vehicles. But this design does not end here, and maybe that's the key takeaway of this whole presentation. What this lab really provides is a way to continually evolve through testing the Shore Control Center concept. One tool we've developed is a simulator. Players of our custom-built video game can control a fleet of digital unmanned ferries. Meanwhile, we can collect data and we can get insights into this new format of seafaring. Bringing it back to our sketch, we can frame our problem as resilient interactions in the AI-human control domain. As technology improves, this line will eventually move to the right, but it will never cover the whole control domain. In this way, our mission is to design for high human control in combination with high AI control. Thanks for watching. Check out the links here for more information.